Good afternoon, everyone. On behalf of edForce, I'm delighted to welcome you all to today's edTalk. IoT, Internet of Things, from concepts to implementation in just 90 minutes. At edForce, our mission has always been to accelerate workforce upscaling by connecting learners with brightest minds in technology. And today is a perfect example of that. We are about to dive into one of the most transformative technologies shaping our world today, the Internet of Things, or IoT. From the devices we use daily to a large scale industrial system, IoT is redefining how the physical and digital worlds interact. And to help us understand it better, we have Tushar Das, Principal IoT Architect and Connected Systems Specialist. Tushar has designed and developed connected solutions across consumer, industrial, automotive, and smart city ecosystems. His approach is hands on, focusing not only on theory but live working implementations that take you from sensor to cloud, even to dashboards. In next 90 minutes, he will break down IoT from concepts to reality, showing us how devices, data, and networks come together to create intelligent systems. I encourage you to listen closely, take notes, and make the most of live Q&A towards the end of the session. Without further ado, let's welcome Tushar Das to take us through the incredible journey of IoT. Can I see a lot of emojis, claps, loves, something fun from all of you? Your reactions really help. Oh, great. I see a lot of applauses. Hi, Tushar. Are you here with us?
Okay. Am I audible now?
Yes, Tushar, you're audible.
Perfect. Thanks a lot for giving me the opportunity to talk through today. Okay, I'm just really looking forward to present certain things which I really love. This particular aspect is very close to my heart. Okay, so yeah, I would love to talk through that. Okay.
Over to you. You may
Fine.
try sharing.
So I can do one thing. I'll try to share my screen first. Okay. I think you have to you have to give me a approval. So it's just sending request. Okay. Request. Have you got a request? Okay. Now I can share, right? So let me do one thing. Okay. Let me first share my. Okay. If I come here, then I choose this one. Okay. Perfect. So I think my screen is visible. I am audible and I can proceed, right?
Yeah.
So, okay.
Certainly,
So
if you can try placing yourself somewhere around the screen, it will be much more interactive, but as you find comfortable.
Is it right now not showing me?
It is showing you in a different box, not on the screen, like we discussed.
Okay. Does it help in any way?
No, you can just pull it off like this. Great.
Okay. Just a minute. I'll just try to do just here. I can just try to change the layout or something. Yes. Is it better now?
Absolutely, we can see you too.
Okay, so this is, yes, this is what I was just trying to do, but yeah, perfect. So let me just do it once more. Always, like this, whatever technology we adopt, ultimately while presenting things, always this kind of initial glitches happens. So I'm just trying to solve it. Hopefully it will work out now. Perfect. And then I go back. Okay. Is my screen visible now? I've shared it. Okay, I'll just go ahead with this. Perfect. Thank you for sharing those emojis and everything, because, like, for me, what is happening today is like I am talking to a set of people. I am and thank you all for joining today. Okay, so we'll be having next 1 or 1.5 hours, or almost we have spent some time. So before I start, okay, what I would like to understand, because as you have already got some introduction about me, I would like to set some expectations, what you can expect from me. At the same time, it'll be good if you can also share some of your questions, some of your queries and all these things. In fact, during my presentations, it can make it much more, in fact, what you can say, like alive. One thing I can tell that, okay, some of the questions, if whatever I see onto the chat box, I can go and answer it whenever I'm just going to take a break or something in between, or definitely all your questions will be answered at the end of the last 10-15 minutes of the session. So without taking much time, let me start today's session with a question to all of you. So what exactly do you think is the Internet of Things? Because I really don't know which particular background you guys are coming from. I understand a lot of people might be aware a lot about Internet of Things. Some people may not know much. Okay. Some people are completely new. It can be a mixed bag, basically. So if some of you can just put in fact, what do you know about IoT, or what is your level knowing IoT? Like, are you a beginner, you are a practitioner, or is it absolutely new? So can you type down these 3 things? You are a practitioner, you are a beginner. Beginner means you have got some basic knowledge, and you are absolutely new. Out of these 3 things, can somebody type so that I can see? Okay, you are a Abhishek. Thank you, Abhishek. Okay, it's a practitioner. Anybody else? Because this will help me. Okay, Mayank, fine, beginner. And anybody is there who is absolutely new to this entire thing called IoT? Thank you, Ashok. Perfect. So Shubhashish, you, Sandeep is a practitioner, Praveen, you okay. So it's a mix of people. But so let me do one thing. Let me set certain expectation well in advance. We are going to talk through, we'll be having a 1+ hours, maybe 1 hour, 10 minutes, 15 minutes, whatever it is. It is not possible for you to learn everything on IoT. It's a huge area. It's a domain by itself. So what we'll try to do, we'll try to give you, break some myths. We'll try to make it as simple as possible for all of you to understand. And I'm very sure even the practitioners, even people who have experience, for you also, there will be certain things which I believe will be new. Okay. So first, before I move forward, let me start with a set of questions. This is normally I ask everyone wherever I train, wherever I talk into the corporate, wherever I talk about IoT. I found out those questions, like not all of them, but some of those questions might be common to all of you. Okay. Some of the questions you may relate to. And if you have any specific questions on your mind right now, you can type it in. And I'll just have a look onto that. During my presentation, I will be answering that, or I will ensure that by the end of the entire presentation, those things will be clear to you. So how many of you, if I ask, like, is there anybody who feels the IoT is another software application? Anyone has got this kind of, so is anyone who feels that, okay, IoT is another piece of software or another piece of software application? Okay. Okay, Praveen, good that you said yes, because yeah, this is one of the things, like majority of the people initially starts with IoT also as another piece of software. Same in today's world, people are talking about AI, ML. In fact, there are multiple things happening. So what I would like to do is to tell you first. Just a minute. Yeah. Let me start with breaking one of this thing. Like IoT is not just a piece of software, or to be precise, there is no specific applications. There is no specific coding language. There is no specific tools which is called IoT. So when we talk about IoT, IoT is basically, it's an amalgamation of multiple technologies. To be precise, it has got electronics, it has got cloud, it has got communication technologies. And in today's world, when we're talking about, it has got a lot and lot of data management activities. We have got edge the controls. Okay, we have got AI agents coming in between and all this. And day by day, the complexity is increasing. It is, instead of becoming it more simplistic, it is becoming more and more complex because a lot of things are coming up. So definitely one thing I would like to tell here before I start and go forward, IoT is not a piece of software. It's a combination of electronics, communication, computer, in fact, systems, and cloud, and multiple other things. So in front of you, I've just given a picture. So when we look into this particular picture, it's basically those are the simplistic hardwares what we use. And if you see onto the left hand side, there is a picture of a watch or something that we call smartwatch. That is one of the simple example what IoT is, or what can be what you can say like IoT enabled device. So this is, let me move forwards to in fact, step by step. And I can tell you that it's a symphony of all multiple different domains. When we move forward, you might have heard about smart refrigerators, smart TV, smart lights, everything today's world, wherever you go and talk about. When I was searching for an Internet of Things picture, there are thousands of pictures, and this is one of the common things. So I just picked it up because I believe everybody is talking about IoT as smart device. So if anybody feels that IoT is, when we are talking about IoT, we are talking about smart devices, please put it onto the chat, or you can say a thumbs up or something. I will come back to that, whether it's wrong, right, whether it's partially right or something. Okay, we'll do that. Okay, Praveen, would you like to ask a question? So you may not be able to ask a question, but can you type it out so that I can take it in the beginning itself, because maybe it will be a common question for everyone. So Praveen, you have raised your hand. You can type your question, because yeah, at the beginning, it is good to have few questions so that I can just cover it up during my presentation. So okay, can I see? Okay, maybe you are typing, so let me move forward. But yeah, and I request Ashutosh also. Ashutosh, if you see some chat, some questions or something
Sure,
coming up, please let me know. Yeah,
for sure.
sure. So let this picture be there on your mind. At this particular moment, let's think about, there are multiple smart devices. And when you see this particular picture, this picture has got the fridge, it has got a car, it has got a light, it has got micro oven things, it has got a coffee machine and all this. And we nowadays we talk about those are the smart machines, which are IoT enabled machines. But what it is actually, it's taking a little time to change. I don't know why. Just a minute. Yeah. So do you all understand that when we are working in today's world, there are two very distinctive worlds. And where we are talking right now, we are talking to you through Zoom. It is a digital platform, right? So there is a very specific difference between certain things which are part of IT, certain things which are IT enabled, and certain things which are not IT enabled. So that's why we called it physical world and digital world. The picture in front of you shows that on the digital world, whatever data, whatever things you have, it can have that, okay, there are certain kind of network connectivities, and you can share data, you can share knowledge, and you can also take actions. I'll just take an example. For an example, you are nowadays doing digital banking, right? So what is digital banking? Somewhere within the list of banks in India, you have got certain accounts. Those accounts has got details of your how much money is left on your account, what is the balance, what kind of transactions you are doing, and all this. And what is that you are doing? You have got a weapon, that is whether it's mobile phone or your computer web page or something. You can log into those information on your bank, on the server of your bank, where your information is, in fact, stored. You can log into that, you can fetch those informations, you can see what, and for that you have, suppose, a secure login, you can do check balance, you can do view statement and all this. Now I've separated two different colors, one on red and one on yellow. So on the other side, you can also take certain actions. So what is that? You can do some kind of transfer funds between different accounts of different banks. You can pay bills and all this. So you can not only see what informations you want, that is the data, but you can also take certain kind of action. So in the digital world, there are two things happening. There is a set of data available on a server. You have got a device, a computer or a mobile phone. You connect to that. You fetch those information based on to your, in fact, information available to you. You can take an action, right? If there is any confusion anywhere, any of you, please just send me a chat message so that I can interact you better. So we all do this and we all know this is happening. This is possible. But imagine why it is possible, because your account information, your name, your address, all these informations are digitally captured, and it is in an IT platform, in a database. It could be stored. That's why you are being able to access that. Imagine on the other side, you have got a physical the device or physical equipment or physical infrastructure. In this particular case, it is a car. Before you start, suppose you want to go from Mumbai to Pune, okay, for a long drive that day, and you'd like to know some basic information from that particular car. If you are digitally connected, in normal ways, nowadays it is happening, but how it is happening? We are connecting this car with some kind of information which can be sent to our mobile. So what are the questions can come in? Let me go one by one. Suppose if you have parked outside in the basement or somewhere at your office or something, you can say, where is the car at the moment? It says parking location is basement. Maybe the next question comes to your mind is there enough petrol available in the car? Imagine on your mobile phone, if it says petrol left 30%. So 70% empty, 30% filled. Next question comes to you, that is the battery charged enough? Suppose it, in fact, gives you back the information, the battery charge is 100%. Next question comes to you, what is the tire pressure? You say, okay, 35 psi, so I'm ready to go. So only thing what I have to do is I have to go fill up the petrol and I'm ready to go. And you would like to know, is there any problem on the car? It says coolant level is okay, temperature normal, performance is okay, after service or whatever information. In today's world, those things are happening. Those things are possible. Those things, you are getting such information on your device, that is the mobile phone, and you can, and based on to that, what is that you are doing? You are being able to take some data-driven decisions. Like, I can start right now, or I have to go via the petrol station to fill up my tank, and then I can go. So those kind of decisions. Now, then I'm just telling you what is IoT. So IoT is one of the technology. Normally people doesn't talk this way. I don't believe on definitions. So I'm trying to give you some kind of examples here and there. So IoT connects physical infrastructure to the digital infrastructure. So what we initially had the example that there was digital data like banking data and all these things that you can access through a mobile phone or computer. But if it is IoT enabled infrastructure, your physical infrastructure can be connected to your digital infrastructure. So you can see the data, what are the data you want to have. And another thing which is very important is you can also take action based on to that. So first point is IoT, Internet of Things, connects physical infrastructure to the digital world. I understand that this is physical infrastructure, but what happens to that? If you see here, there are certain examples. On the left-hand side, we have got given some examples of different digital businesses like our YouTube, the Zoom, we have got digital banking, everything. You already know that if you see onto the left-hand side. On the other side, there are different pictures of a factory, picture of a, in fact, machine, picture of a water boiler, picture of a scooter, and all these things. So IoT enables those machines can be connected to the digital world through IoT. I'll come to that what is that particular connection? What basically, if you're telling the physical device is connected, what does it mean? For a lot of you, we are new to IoT, maybe you will be asking that. So what we normally do on the car side, what we have seen, we try to collect data. It's not that, in fact, so to get those data from the physical infrastructure, we use IoT. How do you do that? For an example, as a human being, what is that we do? We have got 5 senses, right? We have got sight, we have got hearing, we can smell, we can taste, we can touch. So all these 5 senses what God has given us, we can basically touch something, we can smell something, and we can tell what is there. For an example, let's think about this one, that there is something kept in front of you and which is very hot. You don't know that. Moment you touch that through your skin, it will immediately send some information from your nervous system and all this back to your brain, saying that this is tremendously hot. The moment you feel it is hot, you will take some action, and it's happening within nanoseconds, right? Immediately, the brain tells you to take your hand out. So imagine what are the things happening. You are sensing, you are touching, your skin is touching something, that is a sensor. Then it is communicating that signal back to your brain. And your brain is analyzing that particular thing. And it's immediately telling you what to do, what not to do as a reaction. Simple. Those things you are getting it. Exactly. If we have this kind of 5 senses on your body, and there what is happening, maybe you can hear a sound, you can see something. If you are suppose eating something, whether it is sweet, whether it's bitter, all this, you can find it through your tongue, because all the time the same thing is happening. The information is being passed on somehow through your nerves and everything. It's going to your brain. Brain is analyzing and taking a decision, and then you are taking an action, or not all the time you're taking an action. Supposed to find out if there is something sweet. Maybe reaction comes in that you smile, you feel good, you feel happy. So exactly in the similar manner, if we apply the same thing to the world of IoT, what IoT does, IoT connects different kind of sensors to those physical devices. What those sensors does, they takes data, or they take those kind of information back and senses it to a small computer. And there, when they share the data, it can analyze what is it talking about. And this particular function, we basically call it as a thing. So so when we talk about Internet of Things, Internet, we are coming to that. You more or less understood that Internet is somewhere where all the information we are being able to connect. There are multiple different systems, so across the globe, we can get those systems, we can get those data. What is that? enabled us is internet, right? So internet is a connected set of network of different data, different database and all these things. Similarly, Internet of Things or IoT is a internet of such thing. So what is a thing? A thing is a physical device equipped with sensors, being able to communicate and send data. So I'll just take a pause for 2 minutes, not 2 minutes, even for a minute. Is this coming to your senses? Like, can you understand whatever I'm telling? Does it make sense? Praveen, to you, because you are new to the IoT, does it make sense what IoT is? IoT is, so now I'll go deeper into that. But if you are there with me at this particular moment, please use some, what is that, your emojis or something if you're getting it, or please share it on your screen as text messages so that I understand that I'm moving forward in the right direction. Perfect. Thank you. Thanks. Because, like I'll tell you, we are talking about IoT, we're talking about connecting physical, connecting everything. And today when I'm talking to you, I'm talking like a blind. I don't know where you are, what you are feeling at this moment, whether you are lost, whether you are getting my thing. So it's difficult. So please help me. It is not a long time. We'll just go and we'll find out that, okay, how we can make this understandable. Okay. So after this, so now you say out of Internet of Things, what is the thing? Thing is a physical device connected with sensors, which can sense some data and send it back to somewhere. How it will send, we'll talk about through that. So just a minute. I've just given this is now I'm bringing a concept. Don't kill yourself for that. This particular concept we call in industrial, in fact, IoT case, we call it digital twins. Like a physical machine, exactly a digital version of that. I'll just explain a little bit of this particular picture to all of you. What is a digital twin? Imagine, be with me for the next 30 seconds. Imagine on the left-hand side, there is a motor, right? Industrial motor. Now this industrial motor, somewhere the operator is sitting in some other sides of the factory. He would like to know whether this motor is working properly or not. What other things can happen? You can think about, and I'll give you the chance to tell me later, but right now let me explain. Suppose if this motor runs, definitely there will be some kind of power consumption. So if some kind of data you can take from there, that, okay, what is the current it is drawing, what amount of, in fact, what is the ampere, what is the voltage and all this, then what can happen when this motor is running? Definitely there will be some kind of vibration. So if you have some kind of sensors or something which can measure that, okay, the motor is vibrating, that means the motor is running. Okay. Imagine this one. I'll just come to that. The motor is vibrating. It has got multiple phases, but motor is vibrating means the motor is on. Then if the motor is on for 5 minutes, 10 minutes, 1 hour, 2 hours, whatever, it will also generate some kind of heat. So if you connect some kind of sensor which can send you the data that, okay, in the initial 5 minutes, maybe it was just 10 degree. After that, when the motor is running for 5 hours, maybe right now it is 60 degree, 50 degree, 40 degree, whatever it is. So those kind of information, moment you come back into a digital platform, without even touching, without even seeing the physical motor, you are creating a digital version which can talk to you in the terms of data. So a physical machine, a copy of that captured into the digital world in the form of a data is called a digital twin. Okay. So in fact, this is just very high level to you. I'll not go deeper into digital twin, but this is the concept. Similarly, if you see the car, every car in today's world, especially Tesla and all this car, if you go, it's a complete digital twin. Anything happening into the car, anything, where it is moving, how it is, everything is captured. If you see on the other side, there are some buildings. Into the buildings also nowadays it is happening. If the building is generating some kind of energy, how much electricity is being used, okay, what is the consumption of overall water into the building, okay, if there is any kind of poisonous gas somewhere into the building, all this data can be collected from the sensor and a physical data will be captured into the digital world, and it can create a digital twin. That's where we call it digital twin of a physical object. Now, let me put it into the perspective. I've just given this, the Internet of Things is a network of many such things. So now I'll just break one perception. As I asked you, you remember that I just asked you a question that whether a smart fridge, a smart TV, a smart light, is it Internet of Things? Is it IoT? The answer is no. I'll repeat it. Is the smart TV, smart refrigerator, smart light and all this, is it IoT? No, it is not IoT. Those are just enablers. Why is it enabler? Because those are called things. It is not IoT. When multiple such things comes together and takes a logically driven decision, it is capable of that kind of function, then we call this as Internet of Things. So all these things will be connected together logically over the internet. Don't kill yourself if you don't understand this concept a little bit in this particular, because don't try to mug up anything. Just try to understand what I'm talking. So there are more than one, multiple things connected over internet and taking logical decisions. That's called Internet of Things. Thank you. And then I'll move forward. I've just given it here. And now I'll give my own definition. If you want, you can note it down, but never try to mug up next time that, okay, what, because why I have given it, when I go to the internet, YouTube and all this, everybody try to give some kind of definition. And that's how we have grown up. We try to build our definition. Don't try to do that. Understand what we are talking. On to the left hand side, we are talking about internet plus things. What is that integration? It is giving us data. It is talking about a network and communication. And then it is calling about interconnection. I'll come to interconnection in the next slide. So my definition is like this: an interconnected, integrated, logically coupled network of smart devices, which is capable of data-driven decision making. Very complex. If you want, you can note it down. The next thing, next slide itself, it will show you very clearly what it is. For an example, we all talk about home automation and everything. Let me ask you something very silly. You have gone through, a lot of people talks about smart lights. You also might have heard it. Is it? Just send me some, in fact, thumbs up or something, that if you have used or if you have thought about smart lights, what happens? Sometimes people say smart lights, Alexa, please switch on this light. Alexa, please switch on the fan. Alexa, please switch off this particular fan. Or you use, what you have to do is like you have to bring up your mobile device, find out the application, you go to the application, search for that particular light, and from the mobile app, you switch on the light. Imagine the same thing. Why why people just try to sell something which doesn't make sense? Because it is the easiest way to go and switch on your light through the switch you have at the home. If your parents or if our seniors look into that, they will look at us as a silly thing, that why are you telling Alexa to switch on the light when you can go and switch it on? Yes, in certain silly cases, if you are outside somewhere, you want to switch on the light, those things will come to that. But what is happening in the next slide here, if you see, I just given a picture of a smart home. It's not about smart light. I'll spend 2 minutes exactly onto this. Please look into the screen very carefully. If you're not getting, please let me know. Every time I'll just click, some switches or something will come up. That way I've just created some kind of animation. Suppose at the end of the day, you are coming back to your home. It can be apartment, it can be anything. The moment you come to your home, what will happen? You parked on your arrival. There is a lock in the garage. The lock can be opened. You don't have to tell Alexa, please open the locks. What IoT is, it should take logically data-driven decisions automatically. So when you arrive, the lock comes, it just unlocked. After it gets unlocked, you get inside the garage. moment you parked your car, if you see onto this thing, your living room light is on, because maybe from the garage when we'll be getting in, it will be your living room. So you are not telling anybody to switch the light on. It is logically connected, because all these individual things, now you're getting it, like all different kind of things are connected together via internet or some communication system, and it is taking logically driven decisions based on to the data. What is the data? You arrived, the lock unlocked, your garage you parked, so the light here onto the living room knows you have arrived, let me switch it on. After that, moment you come, you have got your bedroom where your AC is switched on, lights are on. Okay, because the next thing, normally, I'm just putting it in logic. Normally, after coming in, you will be going to the bedroom. Now maybe you will be changing and all these things, and you'll mostly will go to take a shower. After that, if you see, automatically the moment you reach your living room, in fact, your bedroom and all this, the geyser is switched on. What is happening? Suppose the geyser is switched on at the same time. I'm just putting up that your coffee machine somewhere in your kitchen that is also switched on. Okay, what happens next? Maybe you have got some washed clothes already available on your washing machine, which you have already cleaned, or it is already cleaned. It is waiting for you to come to take it out and put it outside for, or if it is got a dryer or something, it is telling you to take it out. Imagine most of the time we forget these things, and when you leave those kind of things, especially outside India, we are so habituated and everything, the clothes and everything start smelling. So imagine if somebody gives you a bip after you come, that alarms for washed clothes ready, please take it out. After that, what is happening? When you enter the toilet, automatically your bathroom lights are on. You took your shower and everything. You are coming out after your shower is done. You're coming out, you're immediately the moment you close your door, lights are off, geysers are off. And then what is happening? TV area light is on. You may be now, your coffee is ready. So you'll be coming to the TV area to take, in fact, sit there, watch TV and take a sip of coffee. Next thing, what is happening? Suppose previous evening, you have watched a Netflix movie, which you have only completed 50%. When you switch it on, it will automatically, because nowadays Netflix to everything is all connected to IoT. And you have seen those things happens. You just simply go, open your TV, and your favorite program starts from where you ended last evening. After that, so the TV is on. After that, if you see, when I'm just look into this onto the top, moment you was looking, in fact, started watching the TV, what is happening? The lights on your bedroom is off, AC is also off. Because this is one of the very common thing, and we cannot take Alexa to switch off the AC. To save electricity, moment you are there, nobody is there in the bedroom, the light should not be on, AC should not be on. Because unnecessarily there will be electricity wastage. Now, after that moment you sit there, your car you park there, so it is your charging has automatically, you have charged, in fact, you are sitting there, you are not taking the car out, your charging is on. There are other appliances. Suppose this is on one of our customers, we did it, that they had the small garden irrigation system and all this, in automatically the sprinklers are up. So this is what I'm trying to tell you is, now you got what is multiple things connected together, point number one. Point number two, how data-driven decision making is happening. That is point number two. And third is, without any kind of manual intervention, this entire life of yours, entire multiple physical objects connected together is taking decisions on behalf of your habits, on behalf of your requirements. So this is the enablement of IoT. IoT is not a single smart device. IoT is a logically connected multiple things, multiple devices capable of taking data-driven decision. I will take 5 seconds pause. Is it getting inside your mind? Please put your hands, or just give me some thumbs up, please. It's my okay. Because like I'm just looking forward. I cannot see anyone. Please understand my situation. Okay. So okay, there is something in the chat. So I'm just coming to that. Okay. Okay, thank you, Abhishek. Okay. Now let me, okay, this is some other example actually I have just created. It is for, because of the time today, we don't have time, we'll not go through. This is more or less similar. If we have, because this is, just a minute. Yeah. So this is the smart irrigation and all this. Basically, remember when it is integrated system, multiple decisions are being made. That is where we use IoT and the data and all this. Okay. So now what is the advantage? What is the uniqueness and what is the best thing of this entire thing? I'll just give you some moment here to think why IoT is important. Imagine what happened during the COVID time. When the lockdown started, initially 3, 4 weeks, 6 weeks, people were complete, or maybe 4 weeks, people were shattered, people were thinking what to do and all this. Immediately, the people who are working into the bank, people working into the IT, developing softwares or anything, people who are trying to do, in fact, selling, teaching, so in fact, edutech and all this kind of businesses, whatever was connected, people started interacting with that. There was no disruption. So the digital world, so people wanted to buy and sell things because immediately digital banking was on, your e-commerce sites were on, people started buying, people started ordering food and all this thing. Maybe that is after 2 months or something, but whatever was digitally connected didn't die. Imagine on the other side, if somebody had got a shop, somebody had got a factory, someone was a driver of a car, someone was delivering something physically, all of them not only got stuck, majority of the people lost their jobs. The world was completely shattered, right? If today also the same thing happens, same COVID comes back, God forbid it should not happen, immediately the same thing will happen. What is the prevention? If we connect our physical businesses to the digital world, we can be able to survive through that. And that is what IoT helps, connecting your physical infrastructure to the digital world so that you can, two things you can do. So I'll just come to that. The question is, how do we connect a physical asset to shared data to the internet? Right? This is a common question for the people who doesn't know IoT. Maybe you guys will be asking. Just give me a moment. So here, let me quickly talk about some of the IoT's building blocks. Very simple. I will not go through a lot because I know there are technical people, non-technical people, everybody is there. Very simple 3 things. Note it down. There are 3 things for making any physical device connected to IoT to send the data. The first one is a sensor, or it's called sensing layer. The second one is connectivity. That is, after taking the data, it has to send somewhere, whether through internet, whether it's connected cable or something, whether it's Wi-Fi or something, there should be a connectivity. And then the third thing, whatever data you are taking, it has to be analyzed, right? It has to be processed. And after that processing, it should be visualized or acted upon. Let me clarify this one. I just want to now, please go to the chat, whatever I'm asking, or if anybody has got the answer or what you feel. We are trying to get data from the physical infrastructure. And what we are talking on to the third line is data processing on cloud. We are talking about some kind of dashboard, talking about all this. Does all of you or anybody knows what is the difference between data and information? What is data and what is information? Can somebody type it in? Because I know it's difficult. I normally interact. Okay. Somebody has steered. Abhishek, yeah, data is not collecting information, because collecting is coming to the connectivity. I'll give you an example. If is anybody who can tell what is data and what is information? Because I know those things are very important. Okay, Praveen. Okay, data, digital format, raw form, fine, Praveen. Kanak Dugrat, it is also data 110 deal. Okay, let me take it up. For an example, what is data and what is information? You are your car is in fact IoT enabled and data is raw value, but information is some, is some decision made. Yes, Sandeep, you are absolutely onto the right direction. Let me give you an example. You have a car. This car is giving the data on your mobile, or I can see, suppose me being the father of my son, he's driving a scooty. I put some sensors there. And when he's driving that scooty, it is telling me that, okay, he is driving at 60 kilometers per hour. Okay. So imagine this is the data. Now, what is the meaning of this data? This data doesn't make any sense. Okay, I know that he's driving in 60 kilometers per hour, which is legitimate and all this. Or sometime if he comes back, I can say, why are you not driving slow or whatever. But now imagine this perspective completely changes if you get a second, in fact, second aspect of data. If I scan that area, that from which road he is going, and on that particular road, the speed limit is only 40 kilometers per hour. So now two data elements you are getting. One is he is driving at 60 and the speed limit is 40. That means what? Immediately the processing happening, something is going wrong. So he is violating the traffic process. What will happen immediately? Onto the cloud, onto the decision-making engine. Immediately, if the scooter is intelligent enough, because in today's world, it is happening, it has got camera, it has got radar sensors and all this. It immediately slows down so that camera cannot identify you. But by the time, if the camera is already identified, you are unlucky. There is police sitting there. He will simply click the picture. He will send a challan to you. So now you're getting more than one data points. When it is coming together, it is converted into meaningful information. So only one data points never gives you an information. Information is when one or two or more data points come together, makes a logical output that this is what is, whether it's a traffic violation, whether he's in fact, maybe suppose for an example that in fact you are driving this on some highways where the traffic, in fact, speed limit is 100. It is not a violation, right? So, but you can always understand when information comes to you in the form of multiple data processed together, and when the data is processed, then always remember, please note it down. It is called logically or data-driven decision making. Based on to that data, when it is processed, it is taking a decision, slowing you down, or it is sending you a traffic challan that you have violated the rule. So this entire thing happens through IoT ecosystem. Okay. Let me do, because time is limited. I just wanted to, okay, quickly I'll tell you. I'll not take more time. I'll go a little faster now. Those are the three areas. People who are not accustomed with IoT or something, you can say there is a sensor. I have given some pictures. Those are the very basic sensors normally, which we use and all this for teaching. But normally, I'll show it to you here also. Normally, we don't use it onto the production. Different kind of sensors. It goes to a connectivity network. So now we only know Wi-Fi, we know 5G, 4G and all this. But for IoT, there's a lot of different communication technologies. I'll come to that. And on top of that, those data is normally being sent to a bigger processing system, which is onto the cloud. With big data, with all kind of IoT cloud platforms and all this, it processes the data and it puts it in front of you as a dashboard. So there are three things: sensing, communication, processing, and visualization. I'll move forward. Anybody want to stop me? Because I'm taking some speed right now. If anybody want to stop me anywhere, please do that. This is different kind of sensors, whatever normally we see. We see. Such a short time, I cannot really go through all these sensors and all this, but there are multiple different kind of sensors which we normally put on the physical infrastructure. Some of the names and everything, I think I have given it here. Temperature sensor, proximity sensors. Okay, can I ask you, I know the time is limited, but can I ask you one thing here? When you hold your phone, for all of us holding our phones, has anybody got any idea how many sensors are connected on each of these phones? In an average, every phone will have at least 5 to 10 sensors all inbuilt within your phone. Imagine you are playing a game, and sometime on the game, you remember that you are just doing a speed game and all this, and you just tilt your phone. The car also goes onto the left, tilt your phone onto the right, car goes onto the right hand side. Those are the kind of sensors. Normally, accelerometer, those kind of sensors are there, okay, which takes care of those kind of data and takes decisions. Proximity sensor helps you on certain things like at what proximity, or suppose you are going on a car, somebody suddenly came in front of you and the car makes a break. To take that decision, proximity sensor calculates the distance. And if there is an emergency that, okay, you can, in fact, it has to put an emergency brake, the actuation of decision happens. Okay, somebody gave me a question onto the IT and OT. Okay, so at this moment, I'll just touch base a little bit. So what is OT? OT is basically operational technology. Whatever I told you in the beginning, any kind of physical environment, whatever the physical system, physical machines and all this, when we are connecting it to the digital systems, this is called IT. IT, we talk about databases. IT, we talk about what you call mail systems. IT, we talk about internet. IT, we talk about any kind of application. But operational technologies, like suppose a machine, a conveyor belt. On the conveyor belt, constantly manufacturing or the process is happening one after the other. Suppose a car manufacturing is happening onto a conveyor belt. Somewhere wheels are being fixed. Somewhere steering is being fixed. So all this information, wherever operational side, physical side we are talking about, we normally connect this entire physical side with the IT, and this is two different domains, IT and OT. In a short time, it will be difficult for you to, in fact, for me to explain. But remember, when we talk about operational technology, it is not only, in fact, the physical device, but how and what depends on to the domain. For an example, if a car manufacturer is building a what you can say like safety system for the seat belt. Now the seat belt is, in fact, is fixed there, and the belt has got a capacity to resist a force of maybe 160 kilogram. Or it can also have a belt which can break if there is a sudden impact happens, if the person moves forward. So those kind of things, those information we will have people who understand the domain. So a automobile engineer or a mechanical engineer or somebody will have a domain knowledge about that particular machine, that particular system. IT people will have the knowledge how to take that data, process the data, send it back to the domain expert saying that, okay, this is the data is talking. This is how it is, in fact, reacting. Are you okay? Will you approve this particular system? So IT talks about data, how it is processing and all these things. But actual decision making is based on to the process data. That decision making happens into the operational technology based on to your domain knowledge. An electrical engineer can define what is the domain knowledge of electrical system. A civil engineer can, suppose for an example, you have built a bridge and you have connected multiple sensors that the bridge is moving a little, bridge is vibrating with hundreds of cars. But at what point the bridge can break? An IT engineer will not get that. IT engineer can only get the data that vibration level is maybe, suppose, for an example, in a factor of 1 to 100, vibration is right now 65. But what that 65 means, that is only possible by the operational technology engineer or the domain expert to decide whether it is right, wrong, or whatever things are. So at this moment, I'll stop here. This is how it is. So Abhishek, we can talk things afterwards if we have time on this. Okay. I hope it makes sense. Okay. Quickly, there are two very, very important aspects because now I'll be showing it to you. There is one thing is called sensor. One thing is called actuator. Okay. So sensor is like when from the environment we are trying to read something, suppose the temperature, suppose we are taking how much light in the room and all these things. Those things are physical environment data which is coming up. Based on to that, if we have to take some action, like switching on a motor, stopping the car, switching on a light and all this, those things are called actuators. So this first level of sensors also have got a big factor, which is called sensor and actuator. One is for reading data, one is for taking action. Okay, let me move forward. There are different network connectivities, why it is and all these things. Maybe we'll talk through this later, because remember, for IoT, Wi-Fi is not the only choice or not the suitable choice. There are multiple different technologies. And when we talk about IoT, we talk about simple microcontrollers, not very high processing computers or something. On that, we have to ensure that while you imagine you have got a mobile phone with your Wi-Fi and Bluetooth on, how much can you run the mobile? Maybe 24 hours, maybe less than that. But if you switch off the Wi-Fi, switch off the Bluetooth and all these things, maybe it can run for 2 days. Imagine if a mobile phone cannot run with Wi-Fi or Bluetooth for more than 24 hours. Imagine when we are trying to get a car, suppose parked somewhere for 24 or 48 hours, and there is a sensor which is sending you the data of the location through a communication interface, it will die down, isn't it? After 24 hours, you will not be able to find out what your car is, where your car is. For that, we use some kind of communication technologies which takes low power but wireless technologies. There is a concept called LP-WAN and all this. We'll not cover all these things in deep today. Those are, if you want, you can take a screenshot of those. Those are the different kind of communication technologies which we normally use for IoT. Wi-Fi is just the very basic. For Bluetooth, there is something called BLE, Bluetooth Low Energy. So normal Bluetooth amount of battery it takes, Bluetooth Low Energy takes much lower amount of battery. So just quickly, there are some communication protocols, especially MQTT is the preferred protocol. HTTP doesn't work for IoT. I tell it with complete authority, don't use HTTP for any kind of real-time applications ever in your IoT, because HTTP is not a real-time communication protocol. If you are, in fact, trying to solve a IoT problem with real-time data, HTTP should be immediately rejected. It doesn't work. So there are other application layer protocols, MQTT, QoAP, and all this. I'll not go deeper into that. Okay. Then after all this data comes in, we do processing of this data. We do on the cloud, we do big data processing, whatever. And this is the kind of dashboards we show to people that this is how it works. So suppose on the IoT, in the dashboard in front of you, what is that you are saying? There is some kind of tank somewhere in a location. You have got a GPS location inbuilt onto the dashboard. On the left-hand side, if you see, it is telling water tank, which is 65% water available. Rest is not connected. Then it is talking about the temperature with 86 something. So this is, and there are certain kind of drip irrigation system, sprinkler on or off, all these things. So those on to the right-hand side below, those are actuators. You can initiate the drip irrigation system on or off. Those are the, what you can say, like the sprinklers. So this is a kind of dashboard. So sensor, communication, and this is processing and visualization. So I'll not take any more time here into the detail. Those are the kind of different development boards, different kind of boards and everything, what we used as part of the electronics. There are plenty of electronics items, which just to tell you, to connect a sensor to a device, we need to have a piece of electronics where the sensor will be connected. I'll show it to you right now. So this is normally how, okay, this is normally, we call it a node. So if you see, there is something, we have written it as an IoT node, right here. We have connected some kind of sensors along with them, and the sensors will be giving the data to the IoT node. Then there are some communication channel and all this. This communication, in between there are hardwares, there can be direct also, and it goes to a database or into a cloud environment where you can see the visualization. Okay, so the IoT node normally connects, is a piece of electronics which is called a microcontroller, and those are different kind of sensors onto the top. Gateway and all these things, so I'll come to that. Some gateway hardware, these things. Let's see IoT in action. So let's do one thing. I will try to do one. Let me share my screen. I'll stop sharing here, and I'll try to do. Let me see if I can switch on a camera somewhere else. Okay. Do something here. Can you all see the screen? No, just a minute. Hold on. I've not shared it till now. Okay, some chat. I said in industrial IoT whether MQTT is recommended or. Okay, Ashok, just hold on. I'll give you an answer. Modbus and TCP/IP is basically your hardware PLCs. Your PLCs, when it connects to your SCADA or any other the kind of systems, normally we use Modbus. But when we are sending the data to the cloud and all this, Modbus will not work. You have to send the data, you have to convert that data, and there we normally into the IoT side we use MQTT, preferably. HTTP works, but I will tell you why HTTP is not recommended. But definitely MQTT is the recommended protocol, but you cannot ignore Modbus TCP/IP. Modbus TCP/IP is important because your PLCs understand Modbus TCP/IP. Is that clear? Then you convert that Modbus data into MQTT so that you send it to the cloud. Okay. So let me share my screen. Can you all see the screen right now? I'll switch off the video for a moment. Okay. Just give me a thumbs up if you can see the screen. Okay. Thank you. Okay. Let me quickly do one thing. See those, whatever I'm showing you here are the kind of, suppose this is a sensor. Normally you might not have seen it before. This is a sensor, which is, we call it the Hall effect sensor. What happens, it has, if you see into the top, there is some kind of inlet, there is some kind of outlet onto the other side. What happens, you know, whatever liquid passes through this particular sensor, if you connect it to a pipeline or something, it can tell you how much water, how much fluid, how much water is passing through it, how many liters per minute or per second. Based on to that, you can calculate that in 24 hours, how much water you have consumed. So this is a kind of a sensor. Normally you don't see it on your trainings or anything. So I'll show you quickly something. So let me connect a quick sensor. In fact, I have got a device here, and let me connect a couple of sensors, whatever I have. Suppose, for an example, I have got, you can see those, isn't it? So I'm just connecting. This is a temperature sensor, little bit. Normally, what you see on your studies and all, it is not the same. Let me try to see which are the things I should be connecting to. Okay. Let me connect this one. I'll just take quickly a couple of seconds, and I'll just show it to you. This one, there is a output sound. Yeah, there is it. There it is. If you are not completely, if not completely visible, don't worry. I'll just try to make this thing a little bit. So I have got two sensors here. This one is a temperature sensor. Along with that, let me bring it up. Another sensor. This one talks about any kind of proximity, any kind of distance between two objects and anything. So I'll just try to take this out. Take this sensor, connect it to the connected sensor directly. Okay. I'll connect it here. And then what I do, let me bring in a cable. And let me connect this. So this is whatever I'm connecting right now is basically a node. So if you see here, a light has come up. This particular thing is now connected. Okay. I'll just try to put up one thing here. Just hold on. I'm just trying to put an internet here. Hotspot. My phone internet, I'm just trying to switch on. Okay. Okay, perfect. Now what I will do, you have seen that I have just connected two sensors. One is this particular, this is the temperature sensor. And here I have got one sensor which can measure distance. So what I will do, I'll just quickly share something here. Because this is quick movements and all this, please bear with me. I'll stop sharing and sharing some other window now. Share. Okay. Now, if I go here, oh, why is it? Okay. Can you see my screen? Say yes or no, because I cannot hear any of you. Can you see it is showing what? Temperature is 30
Yes.
degree, humidity is 80.9 degree, distance is 24.29. Let me see if the distance changes by any way. So normally, you know, like in the case of infinity, it should change. So this is what I have done just for a simplification of this entire thing. Okay, just Ashutosh, you are there. Ashutosh, can you tell me how much time is there?
We have 30 minutes.
Huh?
We have 20 minutes.
Okay, okay. So then I'll just show something else also. So this is the kind of sensors I'm talking about. So I'll show you something else a little bit now. What I will do, this is how we connect the sensors. But now what I would like to do, I will show you something absolutely different, that this is different data we collect, but how we take decision and what is dashboarding. Right now, I'm just showing it like everyone shows onto my microcontroller, how this data is coming. Okay, let me quickly take it into the next step. First of all, I will try to share again the camera to all of you. Okay, you can see the camera, right? Ashutosh, my camera is visible.
Yeah, and no, your camera is not visible. In the sense,
Okay,
you are
okay,
not visible, but the products on the table which you are showing are visible.
okay, just a minute. Let me see. Share camera. No, you can see the desk, right?
Yes, we can.
Okay, perfect. Imagine what we have seen. It says and we're told that instead of a mobile application or telling Alexa to switch on a light, okay, what I have done here, that I have just got some connected bulbs and all these things here. What I will try to do is I will just try to switch on something using this is a simple what you can say remote. So I'll just try to switch it on. See here. One by one, everything, whatever I'm just doing, I'm just switching on the lights. Why I'm showing it to you? This is just a way. But what I will try to do right now is I will send you all a quick, don't use this IP address. This is personal IP address, but I'm sending it to all of you. Go to the chat. Just I've sent you a link. Can you open this link? I'll also go and check if this link is working. Click on the link. Is this link working? Ashutosh, please help me.
Which
Or you
link?
guys can put a thumbs up. Okay.
Yeah, it is.
If the link is working, I would like you, somebody. So what I have got, this is an IoT dashboard. What you are seeing here is something that, okay, there are certain control switches. Then there is something called line voltage. Right now, what is the voltage? What is the current flow? It is only showing very limited power, 0.06 ampere, and I'm using 3.9 watt. If you see, I have just switch it off. Yeah. Now I think it will be better. Let me go and check the camera once more. You can see there are 0 watt lights and all these things are on onto this thing. It is showing 4 watts. For an example, now people who are accessing this one, you have got a live dashboard in front of you. Please share the link here, okay? I've shared the link. Ashok, can you use it?
Yeah, I can open the electrical consumption data. Have you shared a new link again?
Just click onto the link.
I have already done. I can see 3
Yeah.
speedometers.
And guys, please see if you can see the link, if you can see a particular page.
I'm sure everyone can.
Okay. Any of you, suppose, okay, something on the chat. No, Abhishek, they're telling it's no, sir. Here we have not received the link.
You have sent it to only host and panelists. Let me share it with you.
Oh, okay. Okay, to everyone. Okay, sorry. Now you must have received it. Just open the link and tell me yes if you can open it. Perfect. So whatever I see, you can also see that. Onto the left-hand side. Okay, first all of you. This is called IoT dashboard. Whatever you can see in front. So now somebody switched on the switch 5, which is a big bulb, right? Just wait and okay, just switch on the switch 5. Right. So if you switch on the switch 5, which is a higher light, moment you see your wattage has increased. Just wait, because normally, okay, now this is a 60 watt bulb, automatically 60 watt has increased. Now you have used another 100 watt bulb. Just wait for 10 seconds and it goes to 167. So now whatever you are seeing right now is basically actuation, real-time data, real-time actuation, all these things. For an example, let me do one thing. So can I operate for a moment? I'll show it to all of you how it works. Okay, so then you guys can do it also. So I'm first switching it off, everything. So, okay, I think switch, the one also is off. You can all see, look into the picture and you can have, okay. Now what I will do is, I have got a little bit bigger bulb, but which is an LED bulb on, I think, light number 7. No, not 7, sorry. Light number 8. You can see the light. Just wait because it has to reset. It normally takes 10 seconds because I've slowed it down because constantly it should not. Okay. So it is telling with this white light, which is giving you enough light, LED light, it is only 8 watt being consumed. I'll switch on another 3, which is 0 watt bulbs. Just wait for 10 seconds. So very minor differences. It can come, it cannot come. It will see to that. After that, can somebody, Abhishek or any of you, yeah, 8.2 now. Can you simply go and switch on the switch number 5? Any of you, you can operate. All of you are, yeah. Wait for 10 seconds. Have you seen how the wattage has gone high? It is a 60 watt bulb, which is now on. Now let's go and switch on the switch 7. Anyone? So now there is another 100 watt which has come up, right? What is the wattage? So this is one of the example in real life how we use IoT, and then I will tell you a couple of things. Now just go down a little bit onto the same this thing. You'll find out some kind of environmental status. What is this environmental status? On my workshop right now, this is the amount of humidity. This is the atmospheric pressure, and this is the workshop temperature. And this is all live. You can operate it from London, you can operate it from US, you can operate and see it from anywhere. The best part of this, when you come here, you can also see what is the usage. See onto the right-hand side. What is the overall utilization of power happening in real life? It is also creating a complete graph for you. You can store it as part of the database and all this. And now I'll give you a wow moment onto that. If you have this system, imagine I am showing it with some kind of bulbs. Imagine instead of a 100-watt bulb, you can also have an AC. Moment you switch on an AC, your consumption of power will be so high. Imagine if you have got a better control at your home, you can now take a data-driven decision like any of these old bulbs. We really all know that LED bulbs takes less power. We all know, right? But have you ever checked it yourself? Like if you are not using, in fact, LED bulbs, using simple bulbs of 100 watts, 60 watts and all this, what kind of impact it has on your electricity bill? Isn't it a not a very exciting thing for all of you to understand that? So those are the systems. This is I'm showing only with electrical bulbs because I don't have, in fact, other things along with me. But this is what happens into the real life is basically, and now you just imagine one more thing, I'll show it to you. Suppose I switched on a couple of lights here and I'm just switching it on. Suppose I'll just switch on the number 1 also, and I'll switch on number 7, all of that. Imagine when I am switching it on, at your system also it is showing the becoming blue, right? So somebody just now was telling me what is the advantage of MQTT. MQTT takes care of, this is one of the thing for all of you. This is the protocol MQTT. It immediately sends you any change into the environment. Whenever I'm switching on a light, it is sending you also on your database or on your screen that, okay, there is a change into this. There is, so suppose for an example, I'll switch on light number 4, which is a heavy light. Now, if you see on your screen, go down, you can see automatically see the graph, how it is changing. So this is some kind of example I just thought of sharing with all of you. And how it helps with this system, if you are aware about that, one is manually you can operate, which is not what I want. But at the same time, now we have got more sensors and all this, which due to the time and all this, I'm not going to show you all this. We have got radar sensors, which finds out what is the presence in any of the room or anywhere. Or suppose into a factory or somewhere, anywhere. Suppose if you are in a big hotel, all your lights in a room, somebody left it open. You don't know. The moment the person comes out, there is no presence detected. All the lights, AC switch, everything will be switched off. Imagine it can save 30 to 40% of electricity bill of a hotel or a home if it is captured and programmed it in the right manner. Isn't it exciting? So this is one part. I just gave you quick this thing. What I will do immediately, you can play with that. It's not a problem. I can just share my screen again. Okay. Just a minute. You can see my screen, right? Okay. So immediately what I will do, why I'm showing it on a live, because I cannot take you into a factory of my clients and all these things, because those are restricted areas. But why? If you can switch on a bulb, you can also switch on a motor. If you can switch on a motor, you can also switch on a pump, an excavator system or anything. Technology is absolutely same. Yes, there are relays, conductors and all these things which works in a different way. Okay, so what I will do, and I will tell you a little bit quickly before I in fact, try to get some questions from all of you. I'll stop sharing here and I'll go back to my PPT. Just hold on. Where is my, okay. Here if I go and go and share again, share. Okay, share. Okay. So what I will do here is, I just lost my this thing where it is. Okay, got it. So quickly tell you what are the capabilities of IoT. Very simple, 4 capabilities I will talk about. Like till now we have seen how to connect sensor, what happens and all this. What are the capabilities? It can do intelligent automation. What you have just done now is not the automation. You have done remote monitoring, like you can monitor what data is being utilized, what you can do with that. So that is remote operations. And the fourth thing is data-driven decision making. So any IoT capabilities, anything we fix up, anything we do, we normally try to do these 4 things compulsory, and then other things goes along with that. So intelligent automation, remote monitoring, and remote operations, and the data-driven decision making. Okay, just hold on before I open it myself for the questions or something. This one not needed. One thing I just wanted to show you. Does all of you, anybody has understanding, or have you ever heard about this one? What is Moore's law or something? Anybody knows? Just give me a thumbs up, or no, it's fine. I'll just connect these dots to now. Why we are talking about IoT at today's world when the sensors were available from last 60 years. Technology, if you see Industry 3.0, this was automation was available from last 25, 35 years almost. It is because there are 2 things. One is we didn't have cloud, so that we didn't have options to process a huge amount of data. So implementation of cloud brought IoT much more faster. Another thing is this average cost of the sensors and the electronics has drastically come down in the last, if you see 15 years. See how the average cost of electronics, microcontrollers, microprocessors, sensors, everything has come down. And why it is? Because Moore's law tells that the number of transistors on a microchip roughly doubles every 2 years, means the capacity doubles for processing every 2 years, where its cost is halved over the same time frame. So whatever was not possible even 10 years back is possible today. We are being able to take those decisions in small microchips, small sensors, and it will now go forward only. It will help us taking things forward. Okay, I'll take a pause here. And Ashutosh, can we go for if anybody has got any questions? I think then we can take those questions, and later also we can answer those things if some time doesn't permit.
If anyone has any questions, please put them on the chat box. Tushar, I think we can just go ahead. Would have there been questions people would have asked?
Just one slide I just wanted to show you. Okay. When we talk, because this short time was not enough for getting deeper into the IoT, I have just opened the first layer. Okay. And if you see what advanced IoT we talk about, nowadays we talk about beyond things, communication, visualization, and analysis, whatever you have seen on the right-hand side. If you see data management, what is called data pipeline. When we talk about data management, there is concept of not only cloud, there is edge computing. So instead of sending everything to the cloud, can we process the data as close as possible to the system, the node or the sensors and all this, and take an action? Data management talks about that. Interoperability means like if Siemens has brought out a PLC and now some other company has brought out another PLC, can these 2 things talk together? Yes, it can talk if there is an open source, if there is an open protocol. So that's where MQTT, those kind of protocols helps. Power management. When we talk about IoT, we talk about simple systems which doesn't have a lot of capacity. Imagine when you are putting an IoT sensor, you are not putting it, suppose in the desert of Rajasthan, you are trying to find out a water tank, what is the temperature, what is the capacity of the water tank. On that, you cannot really have a laptop connected to that. You will be having a small microcontroller. And with a battery operated microcontroller, it cannot be powered, right? So battery operated devices, minimal power, minimal throughput, minimal amount of energy consumption, all these things is part of IoT power management. And on the top of all, at this moment, people are also talking about security. So this is one of the area where advanced IoT, future sessions, future bigger talks can happen, because IoT, whatever we talk today, is just the top of the iceberg. But I hope it has given you some kind of idea to all of you what is IoT. To conclude, IoT connects physical infrastructure to the digital world. Next is IoT provides data. It also requires the communication, and it gives you processing and visualization capabilities. So those are the nutshell. I just applications and all this will not, you have seen so many. I have also given you some kind of examples, but there is so many applications are there into the IoT. Today's session was not talking about onto the high level onto the application, but more onto what is IoT, how IoT works. So I'll, Ashutosh, if it is okay, then I'll just take a pause or stop here. I think that is where the time also is ticking, right?
Great. I hope, and I can see, welcome to the world of IoT applications. Super. We did have a lot of fun. Moving ahead.
Yes. Please ask people to give their feedback and all, so that we can understand where it should take us going forward.
Certainly. Taking the controls away to me.
And should I stop my sharing?
That would be very kind of you.
Guys, I hope you liked it. Please reach out anytime, any more things you need. Okay, because this short 1 hour, 1.5 hours is not enough for such a big technology. We tried our best and we'll definitely do more.
Question answers, I think, have been already addressed. In case you have anything, any questions, anything else you would like to ask, please reach out to me. Our next TED Talk is on AWS Discovery Day, Cloud Practitioner Essential. It's an official AWS session. Please register, go on our website, follow us on LinkedIn, find more about it. I really request you all to write a feedback on today's session on our Google My Business. Find edForce. On the right hand side, you will find our GMB. Please write a review. It will be very kind of you. It really helps us to get you more, better, and really nice sessions. Thank you so much, Tushar, for insightful and hands-on session. It was truly fascinating to see IoT come alive, from concepts to real-world implications, all within 90 minutes. To everyone who joined us today, a big thank you for being such an engaging audience. Your participation and curiosity make these edTalks what they are, a platform of collective learning and growth. If you would like to revisit today's session or share it with your teams, the recording will be available tomorrow on our website. edForce, there's a page called edTalks. We have done a lot of them in the past. We keep doing them every month. Stay connected with us for more upcoming sessions on emerging technologies and workforce transformation. Until next time, keep learning, keep evolving, and as we always say at edForce, workforce upscaling accelerators. Thanks a lot, Tushar, for being with us today.
Thank you, everyone.
To the lovely audience.
Thank you. Thank you.